Welcome back. We're in 57B. This is the second part and the last part of lesson 57. Now we've already learned how to do the X transition from left to right with the sinusoid on the coordinate system. Well, now we're going to learn how to adjust the period. And we know a period so far has been that one rotation occurs within 360 degrees. Well, we can actually adjust that. We can change a period, the length of a period. So instead of it being the standard 360 degrees, we can either lengthen it through division or we can contract it through multiplication. So let's go back through what we've learned so far. So here is the standard sinusoid. It has the origin, 0 is its axis in the middle, the midline, and it has an amplitude of 1, which means that it just goes 1 unit deep, or tall and 1 unit deep. And we have 90, 180, 270, 360 degrees. We do one full rotation all the way around in 360 degrees. Okay? And we know it's a sine because it crosses at the origin. Cosine crosses at the amplitude, and this is a positive cosine because it is crossing at the positive amplitude. It's crossing up. The negative crosses down at the bottom amplitude, right? And we know a negative sign, just instead of going up when it crosses the origin, it goes down. So that's the difference. That's what we learned to start with. Then we learned how to adjust the amplitude by putting a coefficient in front of the sine or the cosine, whatever it was that we had. So here we have a sine, and it's positive. It goes up, and it goes up to 2. So it has an amplitude of 2. So that's why we see y equals 2 sine, because it crosses the origin, and it goes up 2 and then down 2. So that is where that dimension right there is where, let's see, this B, this is our amplitude. This is B sine. All right, so that's where we would have y is equal to 2 sine of theta. Well, this is the B. We can start with the B. We don't have to do the other part. So that's where we started, learning how to adjust that. Now, then we added in how to shift it up or down. So now we have the amplitude here of a 2, but then we shifted it from 0 on the y-axis to 1 on the y-axis. So we can move it up or down on our y-axis by adding a whole number, literally, in front of the coefficient. We say 1 or 2 or 3, whatever number we want that axis to be. And it could be positive, it could be negative. So that would be our new axis. So that is this part. Our y transition is the A value. So we have A, which is where the axis is or where the midline is on our y-axis. And B is the amplitude. It's how tall the wave of our rotation is. So that's where we are now. So then we learned about how to move it left or right, right? So we want to move it to the left from here. Let me take this one off. We're going to move it to the left 45 degrees. So now you can see that instead of crossing the 1 at the 0, it's crossing the 1 at negative 45 degrees. And we know that this is negative 45 degrees because it's x minus and then our degree of measure, and negative makes a positive. So minus a negative makes a positive. So if it says plus, then this is a negative number. So we backed up. And remember, we always do it to the shortest possible crossing. So this is negative 45 degrees. This would be more. So we wouldn't want to go this way. We want to go the shortest way possible. So this negative 45 degrees is how we write this adjustment, this shift. So we've already shifted it up 1 from here to here, and now we have shifted it to the left 45 degrees. And now it's crossing the midline or the axis at the 45 degree mark. which is kind of cool that we learned how to do that. All right, so now we want to learn about how to make this wave different. So let's go back to the original wave that we have. This is with an amplitude of 1. That's just our standard sinusoid that crosses at the origin. It is positive. We're going to make this tighter, and we're going to do that through multiplication. So now if you look, with our green line, we would go through 1 full rotation by the time we get to 360 degrees. With the blue line, we're going through 2 full rotations by the time we get to 360 degrees. And we did that by multiplying our x, or our theta. So that's how we identify that. We have 2 rotations. We doubled our rotations within that 360 degree period. Now we can also loosen it up. We can make it wider and expand it. Here is that divided by 2. So now we only do half of a rotation in 360 degrees. The green line is going to take us 720 degrees to do 1 full rotation, right? So we have half of the rotation here and half the rotation here. So 720 degrees to do a full rotation. So let's go and let's look at that math right quick. So here's how we would figure out what this C is. We know that the standard period is 360 degrees for 1 rotation. Now we're going to take the degrees of the period. So let's look here again. So for this first period, we can go through 1 rotation, that is a period. This period length is 180 degrees, right? This is the purple one. So 1 full rotation is 180 degrees. So what we would do is we would divide that by whatever 1 rotation is. 360 degrees divided by 80, that is going to be C. So let me illustrate that a little bit better. Instead of saying 180 degrees here, let's do 1 rotation in degrees. That's what we would do, right? So our 1 rotation in degrees, that's 360 degrees divided by 180 degrees. That's our value for C. 360 divided by 180 is 2. So our C value is 2. So if we look at this, our C value is 2. We're getting 2 rotations in 360 degrees. All right, and if we look back at this one, look, we have 1 full rotation. That period is 720 degrees. So if we go back and calculate that, right, 360 degrees over 720 degrees, well, we can reduce this. We can't really divide it. We can reduce that and say that it's 1/2. Our C is 1/2. So we would put x over 2 to identify, or 1/2 x to identify that period that takes twice as long to get 1 rotation. And that's how we would find that out. So if we wanted to lengthen our rotation, we want to lengthen that wave and make it looser, we divide. If we want to contract it and make it tighter, we multiply the number of waves, or the number of rotations within that 360 degree period, so that, or within that 360 degrees, so that they're tighter together. We have more of them. So we multiply the quantity, and that gives us a tighter wave, just like we saw. So now let's look at all of that put together. All right. So let's look at this one. Okay, so here we have there's 2 different options. Let's look at this one. So for this one, whenever you have a tighter wave, you're going to do this in order to figure out where that should cross. All right, so we have 2x minus 45 degrees, right? So this is actually minus a positive 45 degrees. So what you would do is you would take the reciprocal of this number and multiply it times the opposite of this number. So instead of a negative 45, that'd be positive 45 times 1/2, which would equal 22.5 degrees. The reason for that is your shift is going to be evenly distributed between the number of waves or rotations within that 360 degrees. So if you've got two waves in that 360 degree period, then that 45 degree shift has to be split equally between both of them. So that is why we would divide that by 2, and we would only see a shift in, let's see if we can find it. So our midline is 2, our amplitude is 4, our midline is 2. It is sine, so it would normally cross at the, and it's a positive because we have a negative here, so it's a positive number. So it would normally, that 45 degree shift would be right about here, but because there's two waves, we would cut that in half, which would bring it to right about there. So that is right. That is where it is supposed to be. It's going to be halfway between, and if you add this shift and this shift together, you would get 45 degrees because it's 22.5 here and 22.5 here. And that's going to happen every time. So instead of crossing here like you want it to, which we're used to, it's pushed out. Whatever this number is times the reciprocal of this number, which means when you expand, the reciprocal here is going to be times 2, because reciprocal is going to be 45 degrees times 2 over 1. But we know this is a minus negative 45, so it's the opposite of this number. That's going to be negative 45 times 2. So our midline, which is 2 here, this should cross at a negative 90, and it does right there. Is that negative 90? That is negative 90 degrees because 2 times negative 45 is going to be negative 90. And I can show you that over here. When we have this x over 2 plus 45 degrees, that shift is going to occur like this. We're going to see the opposite of this number, negative 45 degrees, and that's going to be over 1 times reciprocal of this, 2 over 1. So that's going to be a negative 90 degrees is where that shift is going to occur. So that is how you figure out the degree of measure where it's going to cross the axis or the midline of the sinusoid. So it's kind of cool how that works out, but it's always the reciprocal of this number times the opposite of this number. So the reciprocal of C times the opposite of D, and that gives you where you're going to see that cross the midline. Okay? And this will be applied to every wave, and this will be applied once because you're lengthening it out. All right, so that's all that we have for lesson 57B. You will have a couple practice problems, but what I would really like for you to do is to get on geogebra.org or desmos.com, one of the two, and just start writing some of these functions, some of these sinusoids. You know, put in what you know and then start changing it with what we've learned. Add your A, add your B first, then add your A, then add in your D where you shift it from left to right, and then add in your C where you change either multiplying or dividing, so you can see how that affects the width and the length and the number of rotations within your sinusoid. It's very, Cool. And once you start playing with it, once you change this number around a little bit and do a little bit of math, kind of, does that look right? Then you're going to get a better understanding. You're not really going to completely comprehend it until you've had some practice, until you can put your hands on it and see it. You can do it on your Desmos app. On your phone if you want to. It'll do the same thing there. The one thing I might point out is on GeoGebra, and I haven't tried it on Desmos yet, but on GeoGebra you have to have the degree symbol here in order for it to do the math, to do the sinusoid correctly. Without the degree symbol, it does not give you the same answer. It doesn't give you the right thing. So let me show you how to get the degree symbol. On GeoGebra, if you have Windows, Alt, the left Alt key, plus the O on your keyboard will give you a degree symbol. And that's in GeoGebra. Now on a Mac, if you have, it's the left Option button plus the O, then that's the lowercase o, will give you the degree symbol. But you have to put the degree symbol into GeoGebra or it won't give you the right answer. I'll tell you what, let's go ahead and try Desmos just so I can see the difference. So Desmos, there we go. Just so I can make sure that it does what we want it to. So I'm just going to do a simple left-right translation for the sake of checking it out. So sine of X, and let's do negative 45 degrees. So plus 45. Let's see what that does. I think it worked without having to do anything funny. Let me scroll in. I will say that Desmos works much better on the internet than the other does. So the only thing I don't like about Desmos is with Desmos, you cannot do the degree here, like your little labels. That's why I was on GeoGebra, because it gives you the pi, the radians, which gives you, radians divided by 2 would be 90 degrees, and then the radian itself is 180. So at least you can kind of do your 90 degree thing there. All right, but so this is shifted out 45 degrees. So I'm looking at it. We have an amplitude of 1. So without the 45 degree, let's bring this back in. So without the 45 degree, it crosses here. With the 45 degrees, that's plus 45. I'm going to go ahead and see if I can do the O. No, it doesn't do it on here. So it does not do it. You don't have to do it. Now, on here, it's got the K, the degree of measure there. I don't need that or that. So do not put the degree on Desmos. Without the degree, it does exactly what it is supposed to. The only problem is it doesn't tell you what this degree of measure is here. You kind of have to figure that out. So this is actually going to be, it's crossing the midline or the axis at 45 degrees here. As opposed to, so this must be 45, this must be 90. And I don't think there's a way to change that here. I don't see. Let me see if it'll let me do pi. No, it won't. It won't let me use the pi symbol. That's not what I wanted. I accidentally hit Command Pi. Should be hitting Option P. Oh, there's pi. Let's see. No, it didn't let me do that either. It didn't do anything. So it's not going to really tell you. Let's see if we could do this. No, that doesn't do anything either. So I could take those off and guess, but what it looks like to me is that your 1 is 90 degrees and your 2 is 180 degrees. So you just kind of have to figure that out if you do it in Desmos. If I click degrees, that does not do anything. Radians is what we want. And I don't know why it won't give me that option to actually view the degree of measure in radians, but it doesn't. That's okay. We can use GeoGebra to see those radians down here so you can make sure that everything is doing what it's supposed to. And that's okay. All right, so that is all we have for lesson 57B. If you have any questions, please feel free to ask. And play with GeoGebra. Put in those sinusoids and have some fun. Remember what I said about GeoGebra. You have to put in the degree of measure using either Alt-O if you have Windows or Option-O if you have a Mac or a, I don't know what it would be on a Chromebook. I'm sorry. You just have to kind of figure that out. You could Google what is it on a Chromebook to get the degree of measure in, I guess. Anyway, I will see you in lesson 58. Have a great day.